Hello! Welcome to my first 3D graphics with OpenGL and LWJGL tutorial. And in this video, I am going to be going over creating mesh and initializing an OpenGL 3.2 context for modern OpenGL. Now, if you didn't follow the setup video, I advise you go follow that right now so you can get this starting code here so we can work off of this. If you have, great. Continue watching. The first thing we need to do here is create our 3.2 context. And, well, to get started creating the context, all we have to do is after we create the window, we'll call glfw make context current, and we'll pass in our window. Okay, well, this does make a context, but it doesn't make a 3.2 context, the one that we need. And to specify this, we need to tell glfw the values we need. We need to tell glfw to use OpenGL 3.2. Right now, it's just assuming we just want a normal context. And no one wants that right now. So we can tell glfw what to do using glfw window hint. The first value is what we're telling glfw, and the second value is basically what we want it to be. So let's get the first value in, and you'll see how it works. The first one is glfw context version major, and then we'll pass 3. This is basically saying that we need to give glfw 3 for the major version of our context. We'll also need to hint the window another thing, and that's with version minor. And we pass in 2. We're close, but there's a couple more things we need to do. The first thing is we need to set OpenGL to its core profile. So we can do this by doing glfw window hint, of course, glfw OpenGL profile, and then we'll have glfw OpenGL core profile. And last but not least, if any newer OpenGL version, which I don't see any coming at this point now that Vulkan has been released and it's like at least a year old now, we're still going to need to use this line to be able to access other features from OpenGL 4.5, for example. So we need glfw window hint glfw OpenGL forward compat. And then we'll set this to glfw true. So, now that we have created our context, we can't use any of these newer functions yet. Matter of fact, we can't really use any function at all. And that's because all of the methods, the functions that we're going to be using, has not been initialized yet. We can initialize these functions by calling gl.createCapabilities. And this initializes every function of OpenGL for us to use. Now that we have created this, I'm going to come down here into our game loop here, and I'm going to call glClear GL color buffer bit. And this will clear a nice blank canvas for OpenGL to use. It'll fill it with completely no values at all. We'll just have a completely blank black window. And the next thing we need is to swap the buffers. OpenGL has two buffers. One is in the front and one is in the back. The one in the back is what OpenGL uses to draw our scene to. And the one on the front is the buffer that the window displays. So once we're done rendering our scene, we have to swap these buffers, so that way the one we just rendered to is now displaying onto the window. And this is also the reason why we have to clear the color buffer, because otherwise we'd just be rendering on top of the previous scene that was displayed. So to swap the buffer, we just call GLFW swap buffers, and we pass in window. I'm also going to come up here and import static org LWJGL, OpenGL, and GL11. This imports everything from OpenGL 1.1. All of the functions in OpenGL 1.1 we can now use. Alright, let's go ahead and run. And here is our blank window. Alright, now let's get on to creating the mesh. I'm going to create a new class. I'm going to call this class mesh. We're going to need to import OpenGL a couple of times. We'll need GL11, GL20, GL15, and GL30. So we're getting all of the functions from OpenGL 1.1, 1.5, 2.0, and 3.0. Alright, so the variables mesh is going to have is a couple of integers. One being the vertex array object. The other one is vertex buffer object. And the last one will be vertex count. Alright, go ahead and create the constructor. We're not going to be using this. I actually want to have a method that will create it for us, and a method that will destroy it. So the method that will create it will return a Boolean, and I'll explain why it's going to return a Boolean in the next episode where we go with shaders. But for now, just have it return a Boolean, and you'll see why. So this method create is going to have it's going to want a float array of vertices. And what we're going to want to do is generate the vertex array object. We can do that with glgen vertex arrays. Now we gotta bind the vertex array and unbind it. And after we unbind it, I'll return true. Okay, so inside of the GL bind vertex array scheme we're having right here, this is where we're going to do everything for the mesh. This is where we're going to initialize the buffer. We can do that right now. Vertex buffer object equals GL gen buffers. And this is also where we're going to send the data of our mesh into the buffer. But first we have to bind this buffer. And we're going to bind it to GL array buffer. And then we'll pass in vertex buffer object. Now we have to send the data. So this should be GL buffer data. We're going to target the array buffer using GL array buffer. The data we're going to pass in will be vertices, and we'll use GL static draw. To my knowledge, GL static draw sends this data onto the memory of the GPU. If you use GL dynamic draw, it sends the data onto the RAM, where it would be quicker for us to access and change the data, hence the name dynamic. So we're just going to have it be saved onto the GPU using static because we're not going to be messing around with these data values anytime during our program. So that's it for the create. Now we have to destroy our creation here. To destroy it, all we have to do is just delete the buffer, and delete the vertex array. Vertex arrays. And that's all we have to do to destroy it. Now let's get on to drawing the mesh. I'm going to create another method for this, draw, and the first thing we want to do is to bind and unbind our vertex array. Okay, so now maybe thinking, well, how do we draw this? OpenGL does have a function for that, and it is GL draw arrays. And our mode will be GL triangles. The next value will be the first value, and that will be 0. And then the next value is the draw count, or the vertex count, or for now, it is the vertex count. So we'll use vertex count. Now, it's not going to draw because we're not setting vertex count. So in the create, we're going to set our vertex count to vertices.length divided by 3. Now, it's still not going to draw. We're missing a couple of more calls, both in the draw and the creation. So let's get started with the draw part. All we need to do is enable a vertex attribute array, and that will be 0. And then go ahead and copy and paste, and then change it to GL disable vertex attribute array. Now this will allow us to use a specific index that we have not yet defined to draw. And this leaves us to the create. OpenGL has no way of reading this data correctly. It has the data, yes, but it doesn't know how to read it. When we send data over to OpenGL, we can send anything. We can send float, we can send bytes, we can send integers and doubles. But OpenGL doesn't know what data it is. So we need to tell OpenGL what data it is and how to read it. This could be achieved using this function right here, GL vertex attrib pointer. Its index is going to be 0. What this means is that it's going to be the first way it knows, it's going to be the first piece of data or the first information it's been given to read the buffer for our vertex array object. And when we bind this vertex array object, we have to enable our little attribute pointer here so we can use it. Otherwise, it's not going to find it. It's not going to look for it. It's basically useless data that we just gave. Alright, so the next function is size. This is going to be set to 3 because we have x, y, and z values. If you were making a 2D game, this would be 2 for x and y. And if you watched my previous tutorials on using LWJGL, which is now 2D game development, the beginning goal of the series was to kind of be 2D, but easily converted to 3D. And then it just went from 2D from straight on out. But this is going to be for 3D and 3D only. So we're going to use 3. X, Y, and Z. Now the next value is type. What type of data are we given OpenGL? Well, it could be double, it could be floats, integers, bytes. This is what we send OpenGL. GL float, because we're sending it an array of floats. So we want OpenGL to know that the data value is indeed a float. The next is a Boolean, and this is normalized. We don't want it normalized, so leave that at false. The next is stride. Go ahead and leave this at 0. We're not striding. We don't need to jump past a bunch of other useless data values. And then pointer is going to be 0. Now, the only reason why stride would not be 0 is if inside our float array you were using position, texture coordinates, normal values, and tangents, and bitangents all within that same array. And this is what stride does. It'll hop over those values so we can get the next position. Or if you were using textures in that same thing, in the same array, this stride would be the same as it would be for the position, except this pointer here would be a different value. I'll go over that when we need to add more values to our array here. So just leave these two at 0. Alright, that should be it for our mesh class. We have told OpenGL what to do with the data we send to it. We're telling OpenGL to draw it. All that's left now is to create this mesh inside our main here, our main class. So under GLFW window show, I'm going to create a mesh, and I'll call it test mesh, and this will be equaled to a new mesh. All we have to do is test mesh.create, and we'll send a new float array to it. The first value will be -1, -1, 0. Our next vertex will be 0, +1, 0, and then our last vertex is +1, -1, 0. And this should create a triangle. Now, of course, we need to destroy our mesh right after. And let's go ahead and draw our mesh. Why isn't it showing anything? So you may be wondering, why isn't it showing? Or, why am I not getting anything but you are? See, this is a spot where everyone is going to have a different result. You're either going to not have the triangle, or you're going to have the triangle. For the people with the triangle, the way we have our mesh set up, you don't need a custom shader. But for the people who don't have a triangle, including me, our graphics cards require a custom shader in order to render this triangle. And I'll be covering shaders in the next video. I'll see you at that video.